For this video, we are to prove that if A is greater than B and B is greater than C, then A is greater than C for all A, B, and C element of real numbers. This is what we also know as the transitive property of inequality, which tells us that if there are three different real numbers and it follows this criteria, that would mean we can cut out the middleman and say that A is greater than C. But of course, we're going to show the proof here using some properties that we have learned in real numbers together with some concepts that are related to this. Okay, so before we start with our proof, we are going to use or introduce here the set of, this set. Okay, set P is also known as a set of positive numbers. Okay, so we have positive numbers, that's actually all numbers greater than 0. And since P is just a subset of R, this is a subset of R, that would mean it also includes all the rest of real numbers as long as they are all positive. The point of sharing this is because there is a definition if we say that if X is greater than Y, okay, we can rewrite this as X minus Y, and the result here is an element of P. We are going to use this as part of our proof later on because this shows that whatever will be the value of X, it may be too large or too small, as long as it's greater than that Y, once you subtract Y from X, it will always be positive because X is first and foremost greater than Y. Okay? So hopefully that's clear here. Now, since our point here is we are proving this, we are going to show that for A is greater than C, then it tells us that A minus C is an element of the positive of real numbers, which is connected to this idea. Okay, so we are going to use this definition not just for the item we are trying to prove, but even for these two statements here. Okay, so let us start with our proof. Of course, we let A, B, and C element of real numbers, no matter how small or how large it is. And that we're going to come up with this assumption: A is greater than B and B is greater than C, because they're all part of the assumptions. What we're going to show later on, as mentioned, is this portion here where A is greater than C, or once we reach this point, then automatically we can say that A is greater than C. So how do we show this? So if we are going to have these two statements, so it also follows this idea here. So if we're going to say here, then A greater than B means A minus B is an element of positive real numbers. Okay? This is also true for B greater than C as part of our assumption. This yields that B minus C is an element of positive real numbers. Hopefully you're following. We're just using here the definition described by this. Now, what if we add both of them? Okay, so what if we add, let me change the color to black. Okay, what if we add these two statements? If we're going to add A minus B plus, so we have here, now let us use the word now. Okay, A plus B and B minus C. Is it still an element of positive real numbers? The answer is yes. This is one of the properties of positive real numbers, where the sum of positive real numbers are also positive real numbers. That's a closure property for the set of positive real numbers. Hence, they are still element of P. Now, let us try to break down the grouping symbol. So you have here A minus B plus B minus C is still an element of positive real numbers. Let us not remove this because we intended to show this relationship later. Okay, so once you can look into that, notice that we have here inverses. And if we're going to add them, that's A plus 0 minus c, still an element of positive real numbers. Removing 0 in the middle, you have a minus c, element of positive real numbers. And what is this actually? This is what we would like to show earlier, which is also equivalent to that. Because per definition, if the difference of a and c is an element of positive real numbers, or in short, if it's positive, then we can say that a is greater than c, because that is only true if a is greater than c to have a minus c still a positive real number. And as you can see, this is what we are trying to prove here. So let us not use then here. Let us use therefore as the final statement. Therefore, or thus, a is greater than c. And this ends our proof. Okay, so this transitive property of inequality uses the set of positive real numbers as part of its proof, and this shows that then again, if a is greater than b and b is greater than c, we have shown that a is greater than c. Thank you very much for watching.